Question number 4. Okay, so this is based on an inclined plane. 22 kg block slides down a frictionless slope which is at an angle of 20 degrees starting from rest. The time to slide down is t equal to 1.9 seconds. The acceleration of gravity is 9.8. What is the total distance traveled to which the block slides? Okay, it says it's a frictionless slope. Okay, and essentially if something's frictionless, ideally it would keep sliding down, but we are capped by this time t equal to 1.9 seconds, so that's all the duration we can slide down for. So we need to find how much this block slides down given this much time. Okay, so let's copy this diagram over. All right, and let's first write the equation of motion, which would help us solve this. So we're given we're at rest and we know the time, so we would use S is equals to ut, which is initial velocity, plus half at. I think that's the equation. Yeah, half at squared. Okay, so since the initial velocity is 0, this term goes away and we're left with half at squared, where a is the acceleration, t is the time. We know that time is equals to 1.9 seconds and we need to solve for s. Therefore, the only unknown is this equation is acceleration, which we can solve for if we prepare a free body diagram. So let's make a free body diagram for this. So we have an inclined plane and we have a block which is at an angle 21 degrees, and this block is 22 kgs. Okay, so we know that. So what I'm going to do is the first force which acts on this is the force of gravity, mg, and there's no friction, so we can ignore that. There's also a normal force which acts on this, which is from the contact with the surface here, and we can resolve this mg components into two components. So we would have the sine component, mg sine of 21 degrees, and we would have the cos components, mg cos of 21 degrees. Okay, if we look at the sum of forces along the surface of the plane, we only have mg sine of 21. Therefore, F is equals to mg sine of 21 degrees, and F is equals to ma is equals to mg sine of 21 degrees. The masses get cancelled out. We're left with A is equals to 9.8 times sine of 21 degrees, which is equal to 3.51. So we get 3.51 meters per second squared. And if we plug that back into our equation, which was S is equals to half at squared, we get half times 3.51 times time, which is 1.9. Therefore, this becomes 2.51 times 1.9 squared times 0.5. 6.33 meters. Okay, so therefore this block slides down 6.33 meters before it, or in 1.9 seconds. So let's just write that down. The block slides down the inclined plane 6.33 meters in 1.9 seconds. Okay. Alright, so that's the final answer, and they have gotten the same answer as well. So they used the free-body diagram, but they did not show the free-body diagram, which I highly suggest we prepare every time we're solving any box-related question. Then we use the equation of motion. Since it's at rest, we get, so the answer is correct. So I'm going to mark this as incorrect because I personally do believe that we need to show the free-body diagram every time we do a question like this. Free-body diagram of the block in order to better understand how we got the equation A is equals to G sine theta. Okay, so I guess mark it as correct and give them some feedback on it. Alright, next step.